Now we've reached our first plot center, and I've marked it in the ground with this pin. I've also put a label on it, which indicates which plot number it is. So the label says plot number 1, which corresponds to plot number 1 on my forest map. This is important because when I collect information here, I'm going to want to be able to check that information, and I may want to come back and visit the same place in the forest. This enables me to come back if I need to get more information. Okay, so the next thing to do is to explain how fixed radius plot sampling works. So fixed radius plot sampling is basically making a circular plot in the woods. It's taking an area of the forest that's circular in shape, and we're going to count and measure the trees in that area. This is a 100-foot measuring tape, and we're going to use this to measure the radius of that circular plot. Now, when I'm working by myself, I'm going to hook the measuring tape to the center of this pin, and I'm going to stretch it out and measure the distance to each tree and to the edge of the plot. Now in this case, I'm using a 20th acre plot. So that means in total area, 20 of these plots would equal the area of 1 acre. A 20th acre plot has a 26.3 foot radius. So any tree that's within 26.3 feet of this plot center would be in the plot. Now, the way I proceed is I usually mark a tree that's very noticeable and very close. So I'm going to start with this tree right here, and I'm going to take a piece of chalk and I'm going to mark this tree. Okay, I'll call this is going to be tree number 1. Now I already knew that this was within 26.3 feet, but I'm going to measure it just to show you. So this tree is actually 5.7 feet from the plot center. Okay, so this tree would be in. Then I would take my measurement equipment, I would take all the measurements I need to take on this tree and go on. Usually I'm going to have a data sheet that I create in advance, such as this one I'm showing here. And this data sheet will have all the numbers that I'm going to collect, all the measurements I'm going to take on the trees, things like that. So I'll have a list, tree number 1, tree number 2, tree number 3, etc., of all the trees that were on this plot. Okay, so I've showed you a tree that's clearly in. How do we know which trees are in and which trees are out? So let's find a tree that's not in. So I'm just going to walk back until I'm 26.3 feet away. So 26.3 feet is right here. This tree is not in. So I'm going to make my way around the circle, and I could go clockwise or counterclockwise. And I'm going to check each tree. This one's exactly 26.3. That's what we call a borderline tree. This is a tree that's half in and half out of the plot. So if a tree's half in and half out, we have two choices. We could measure it and count it as half a tree, or a simple rule is to measure every other borderline tree. So I would measure this one, but the next time I had a tree on the edge of the circle, I wouldn't measure that one. In another video, we talked about a laser rangefinder. A laser rangefinder is a tool that enables us to bounce a laser off something and determine its distance. Well, what I can do with the laser rangefinder is I can stand over the plot center, and then I can point it at a tree. I could shoot the laser at the tree, and it'll tell me how far away it is. This tool stops us from having to drag the measuring tape through the forest, which sometimes gets tangled up, and it gives us a more efficient way of measuring the distances to the trees. Now basically, As I go around the circle from tree to tree, I'm going to go all the way around and count every tree and collect all the required measurements on the trees as written in whatever measurement protocol I happen to be using, which we won't discuss here. But I'm done when I go all the way around and I go back to the tree that I started with. Once I finish counting and measuring all the trees, then I'll pick up all my equipment and I'll head off to the next plot.